So, hello everyone. So, we will be discussing the longest increasing subsequence problem. So, the problem is to find a subsequence which is a part of the array in the same order, but not necessarily contiguous, where each number is strictly larger than the previous one. So, our goal is to find both the length of the longest increasing subsequence as well as the actual subsequence itself. Okay. So here, suppose for example, if you consider this array, right? So the longest increasing subsequence is this part of the array, 10, 22, 33, 50, 60, 80. Okay, the length is the same. So we need to find out this one. Okay. So the approach we'll be using here is dynamic programming approach. So we use two arrays. So one is to store the length of the longest increasing subsequence ending at each index. Okay, that is the LIS array. So previous array, right? So and this one, like in order to print that in a longest increasing subsequence, we need to remember it, right? Somehow we need to backtrack it. So the previous array is used to remember where the previous element of the subsequence is. So this helps us in both finding the LIS length and the reconstructing the sequence as well. That is, for example, the key idea, right? For each element, that is ith, suppose there is an ith element in the array, compare with all the previous elements. That is, if array of I is greater than array of j, update both LIS of I and previous of I. Okay, how we need to update that we will discuss in the coming slide. Okay, so here, so we'll try to dissect part by part. So see this first, right, n, LIS and previous, right? So they are the kind of initializing the variables or these two arrays as well. That is, LIS, as I said, stores the length of the longest increasing subsequence ending at each index. So we initialize every entry to 1 because every element can be a subsequence of length 1 by itself, right? So that's why they are initialized with 1 first. Similarly, the previous one. So this array, as I said, it will help us to reconstruct the subsequence by storing the index of the previous element in the LIS for each index. So initially, all the values are set to -1. So meaning no previous element is tracked yet. Okay. So now this part of the logic, right? So this part of the logic is now given array. So how should we fill these entries in the list as well as the previous? That is, the list means longest increasing sequence, and the previous means. So as I said, it is basically helps in reconstructing the sequence. So this part of the code, right? Basically, it requires order of n square, right? Because there are two for loops. Now, suppose what we are trying to do is just try to understand. So for each element, array of I, right? For this outer for loop, for each element, we are trying to compare all the elements up to I. So if array of I is greater than array of j, so we can think that jth element is part of the increasing subsequence. Okay, when it comes to ith position. So that's where LIS of I is LIS of j plus 1. Okay, so that is so if I want to put it in crisply, you can think this way. If array of I is larger than array of j, we can form a longest subsequence by appending array of I to the subsequence ending at array of j. Okay, that's why we are forming this one, right? Similarly, previous of I is equals to j. Why? Because we need to keep track of this one. Basically, this step is it keeps track of the index of array of j to later reconstruct the subsequence. Okay, this nested loop is of course, as I said, O of n square. Okay, now next is the max length is of course. So once we filled up LIS, we can take the maximum element present in that list. Similarly, the max index. So we need to pick index of the maximum number present in the LIS array. or similar, this part of the code is basically once we got LIS, right? LIS and previous. Now we need to find out the sequence from these two things. So it is in a way backtracking it. Okay. So basically we need to find the maximum value. After finding the maximum value, max index here, that helps us to locate where this longest subsequence ends in the original array. So we can backtrack from there to get the full sequence. Okay. So this part of the code, we backtrack from max index to reconstruct a sequence by following the indices stored in the previous array. Okay. For each max index, we append the corresponding element from array to the result. The loop continues until max index is -1, which means that we have reached the start of the sequence. So finally, since the subsequence is built in a reverse, because we're starting from the max index, so we need to reverse the result. So that's why we are doing this. And the function returns both length and LIS itself. And the time and space complexity, as I said, there are two for loops involved, so order of n square. And the space complexity is, as we use two arrays of size, LIS and previous, to store the length of LIS. So it is O of n. So space complexity is O of n and time complexity is O of n square. Thank you.